Hello, Trig. The last little segment we'll be doing is a couple days on a thing called matrix algebra. I've never seen the Matrix movie. I don't know if any of you have, but I don't believe this has anything to do with anything that has to do with that movie. A matrix in math is just a rectangular array of numbers. And so the original usage of this was to solve systems of equations. And so that's what we're going to do today. This will probably be the hardest of the days that we'll do on matrix algebra. So if you get freaked out today, every other day will be easier. You can look forward to that. This isn't the thing where the chapter gets worse day by day like usual. It actually gets easier as we go. But the original usage of this was to solve systems of equations. This is a system of equations that has 3 equations and 3 variables. So that could be called a 3 by 3 system. I'll come back to that. I'm going to start us with a 2 by 2 system that has 2 equations and 2 variables. So at the top of this, if we were live and in person, I would have probably done like an Algebra 2 review that doesn't necessarily pertain to this lesson, but in Algebra 2, we did these things together. One way we solved these systems of equations was by graphing them. One equation made one line, another equation made another line. The solution would be the one point where they crossed. Another way we used to do these was a thing called the substitution method. Like for the substitution method, we get this x alone. X would equal a bunch of junk with y's. We'd replace this x with a bunch of junk with y's. And then this equation would only have y's, and we could solve it forward from there. We also did a thing called the multiplication addition method, which is more what we're going to be after today. The multiplication addition method involved on having opposites or making opposites so that we could add together some opposites and make variables disappear. Like if I could make this have a -2. When I added those together, the x's would vanish, and that would be the quickest way to get after the y's, would be to find some way to create opposites to vanish the x's. So the top of this is just sort of like a algebra review we probably do in person, but I'm just not feeling that today. So like I said, a matrix is a rectangular array of numbers. What we're going to do when we go to solve these today, allowable moves are to swap the rows. Anytime you want to switch the rows, you could. It's generally desirable to have the smaller x on top of larger x's. So I like that one. This has a smaller x on top of larger x's. I like that one. This has the smallest x on the bottom, so I'm going to do some switch arounds when we get to that one. This one has the smaller x's on top of the larger x, so I'm not going to really swap that. I'm going to leave that be. But one thing we're allowed to do that I'll take advantage of sometime is to switch the rows. Another thing we're allowed to do is multiply or divide a row by a number. So if I want to create my opposites to make eliminations happen, I'm going to need to multiply that row by a number to make those opposites exist. And like we've always done with equations, you can't just change one piece. If you're going to do something to one side, you have to do the same to the other side. And you're going to have to go all throughout there. The third thing we're allowed to do is add these multiples of rows together. So I'm going to do this 2 by 2 first. Even though it's not the first problem in the notes, it's on the notes. So I'm going to do this one because I think a 2 by 2 is an easier way to start the lesson. So to make this matrix, when you're looking at the system, we're going to just copy the coefficients, the numbers in front, in columns. So the x column, there's an invisible 1 and there's a 2. So I'm going to write a 1 and 2 in the first column of numbers. 3 and 5 for the y's, I'm going to write 3 and 5 in the second column of numbers. Where the equal signs are, I'm going to do this little dot-dot-dotty kind of dotted line. And then 7 and 12 live over there. What I'm always after is trying to use this top left corner to make zeros under it. So I'm happy with a 1 there. This top row, I can just keep it the way it is. But I'd like to use this 1 to create some opposites and eliminate the numbers underneath it. and make zeros underneath that top left corner. So for me to use this 1 to eliminate a 2, I would need to multiply by -2. If we think about doing this the long way, I could multiply -2 throughout this whole problem, create my opposites so that the x's could eliminate. I'd multiply through by -2, and then I'd add the numbers together. What I'm going to do in matrix form is the same thing, but with less handwriting. I'm going to multiply by -2 and add down to make 0. I'll multiply this by -2, so I'm thinking -6, add down, that's a -1. I'll multiply this by -2, that's -14, add down, that's -2. I multiplied this whole top row by -2, so I would create an opposite here, and then I added down to kill the number, the 2, to make it a 0. I want to always have a 0 below that top corner. If I lost you, rewind that, watch it again. If I still lost you, fast forward and watch the beginning of the next one. What we look for here now is to solve this equation. I just killed the x off, so if you have to write it, you could write it. What this represents is that -1y equals -2. This was the x column, this was the y column, that's the number column. So this is representing -1 times y equaling -2. In other words, y is 2. For us to write an ordered pair, we're halfway up. If the y is 2, if you're more comfortable plugging in up here, I guess you can. The y of 2 can plug in anywhere. If you want to plug in a y of 2, 3 times 2 is 6. The x is adding 6 to equal 7. The x has to be a 1. I'd probably plug in here though, because I would have never even written that down if it's my homework paper, I don't think. I'd be thinking a y of 2 can plug in here. 3 times 2 is 6. X plus 6 is 7, so x is 1. You could have plugged the 2 here also. 5 times 2 is 10. If 2x plus 10 equals 12, that's also an equation that would get you to 1. And you can always plug these in to check. On the homework paper, I ran off a homework paper out of the book because this is coming back out of our old friend, the Algebra 2 book. Ugh. So if you were here in person, I'd have given you a book and we'd have worked through this book some, but you're not here, so I just copied the page and gave it to you. I wrote all the answers on the page too, to just speed you up and know if you're doing the right thing. Across the line, here's another 2x2 system. So if the book had this, I would copy down 2 and 3 in a stack of x's, 8 and 5 in a stack of y's, 5 and 4 in a stack across the dotted line where the equal sign goes. This top equation, I'm just not going to mess with it. I'm just leave it. But what I'd like to make is a 0 in this position below that top left corner. Any number below this, I'm going to make a 0 there. When we go to do a 3x3 in a minute, I'm going to have more zeros to make. But I want zeros below that top left corner. So I need these numbers to be opposites. So for 2 and 3 to become opposites, without using fractions, the smartest thing to do in my mind is multiply 2's row by 3, multiply 3's row by 2, and then to make them be all the way matching opposites, just pick one of those numbers to be negative. I'll pick that one. So I'm going to multiply this by -3. I'm going to multiply this by +2. And then I'm going to add these together. So this is -6, added to +6 makes the 0. I chose those numbers specifically because they give me the 0. Multiply is -24. Multiply is 10, I add them together, that's -14. These multiply to -15, these multiply to 8, adding together is -7. Now that I've eliminated an x, I can get the y from this problem. If you need to write out -14y equals -7, feel free. But the idea behind this is that you're trying to like not write anything. That's why people invented this, as a way to write this in a lot shorter way than what it used to take us to fill large swaths of the board to do this. If we divide by the negative 14, 7 on top of 14 reduces to a half. So for our answer, we'll write it as an ordered pair. The y always goes second. And then figure out a place to put the half in. If I put the half in here, 8 times a half is 4. So 2x adding 4 equals 5. Do some opposites. Subtract the 4 to get 1. Divide by 2, it's also a half. If I just lost you in the last 30 seconds, then maybe you want to write out more stuff just to survive. And write 2x plus 8 times a half equals 5. 2x plus 4 equals 5. Subtract the 4 is 1. Divide by the 2 is half. That's more writing to get you the same answer. But again, the idea is to try not to write the steps. But if you got to write the steps to survive, you've got to write the steps to survive. I'll take a stroll back to the left and do this 3 by 3. This is the first problem from the notes. X's, I have 1, 1, and 2 stacked. Y's, I have 1, negative 2, negative 1 stacked. Z's, I have 1, negative 1, negative 2 stacked. 4, 1, and negative 1 in the stack across the dotted line. And then I will always make sure I copy my problem right, because that's often what went wrong, is that the problem got copied wrong. This is going to take more work than the 2 by 2, obviously. Like the 2 by 2s, that top row need not change. I'd like to use this 1 to make zeros all the way underneath it. So for me to use this 1 to get rid of this 1, I just need to switch the signs of either of these rows. Doesn't matter which one, and then I'd like to add them together. I'm always trying to make opposites and then add them together. So I'm going to switch signs of this, because I can see I'll get more positives if I switch signs of this. Switch the sign of this and add it to that would make my 0. Switch this, add it to that is a 3. Switch this, add it to that is 2. Switch this, add it to that is 3. For me to make this a 0, I need this to multiply by negative 2. So I'm going to multiply by negative 2 and add to make the 0 I already made. Multiply by negative 2 and add to make a negative 3 there. Multiply by negative 2 and add to make a negative 4 there. Multiply by negative 2 to get negative 8 and add to get negative 9 there. What I would do next is examine these, and if one of these was really bigger than the other one, I would swap rows to get the little number in the middle. These are equally sized, so it doesn't really matter. Okay, so the first step, I copied the first row. The next step, I'm going to copy the first row and the middle row, potentially having switched the order and just keeping the smaller one. I already made my zeros on the far left. What I'd like to now do is make a 0 in this position by hopefully adding these two together. These two are beautiful. I add these two together right now, and I got my 0. So I can add these two together to get a negative 2. I can add these two together to get a negative 6. This is called an upper triangular matrix, meaning the numbers are in a triangle shape on the top with all zeros underneath. That's the shape we have here too, and here. When you have yourself an upper triangular matrix with the bottom corner filled with zeros, that means it's time to solve and get answers. This means that negative 2z equals negative 6. In other words, if you divide, z is 3. This is going to have an ordered triplet, x, y, z. plug that 3 in here. This is telling us that 3y plus a 6, because 2 times 3 is 6, equals the 3. Subtract the 6. Divide by 3, that's -1. The top equation can get us x. This is an x plus a y, which is -1, plus a z, which was 3, equals 4. Those make 2, so x must be the other 2. You can check those in all the original problems, they work in all of them. I'll do one more 3 by 3. So for this one, I switched the rows. So this is the last one from the notes. I did the 1, -2, 3, 4 equation to the top because it had the smallest x. And I'm going to just copy that row into my next step. The 2, -1, 1, -1, I put in the middle because that was the second smallest. The 4 I relegated to the bottom just where it's not going to be as much of a bother to me. For 1 to bump off 2, I need to multiply by -2. So I multiply by -2 and I add to make 0. Multiply by -2 and add is 3. Multiply by -2 and add. Multiply by -2 and add down. Then I forget all about that -2 and I use the 1 to turn the 4 into a 0 by multiplying -4. So I multiply -4 and I add, that's 9. Multiply -4 and add, that's -11. Multiply -4 and add, that's -15. When I go to the next step, I'm going to copy the top row. And I'm going to copy the smaller of these two numbers. If these were out of order, I'd switch them. But I'm pretty happy with that 0, 3 thing going next. And I devise a way where the 3 can kill that 9 and make the 9 a 0. For 3 to kill 9, I need to multiply by -3, so that's a -9 that kills off the +9. So I'm going to multiply by -3 and add down. Multiply by -3 and add down. Multiply by -3 and add down. And I have no idea why I wrote this, because I don't need that at all. I have myself an upper triangular matrix. This bottom level can tell me that the z is 3. If I put a 3 in here, -5 times 3 is -15. I'll do an opposite to add 15 to get 6. 6 divides by 3 to get 2. And the 2 and the 3 go to the top. 3 times 3 is 9, remember the 9. 2 times -2 is -4. To go with the 9 I'm remembering is 5. X plus 5 is 4. To undo adding 5, subtract 5, and I get -1. You plug those in and check, and they work. If you were more comfortable when I was showing more work a minute ago, then show more work to be more comfortable. If you're fine where I just didn't write anything and I just did the opposites in my mind, then do the opposites in your mind. It's all good, you do what you need to do. So page 186, I think, is the homework page I ran off for this. You'll see it. It's systems of equations. It will say to solve them. It's whatever the first lower page is. See ya.